So yeah, good evening everyone. So we'll be starting our class. Kindly confirm the audio is good before we proceed. Great. So we'll be starting our class. So today we'll be building up on what we've been doing over the week. And what we've been doing over the week is the Linux and Bash. And also we'll be talking about collaboration and security because as we know, collaboration is very fundamental in DevOps and the security aspect of it because we've been transiting from DevOps. It's not like we are leaving DevOps out, but we've been transiting from DevOps to DevSecOps and other mutation of DevOps. Where you get the IOps and the MLOps. But that aside, so we'll be looking at the security side of DevOps. So as a DevOps engineer, which culture you should like drive for your team, which practices you should be cultivating, and also for you on your day-to-day jobs, but also for the team that will be supporting in various areas. So first part we'll be doing labs. So the labs for today we have 3 parts of the labs. So the lab today is for Linux, and we are trying to have some scenarios. So these scenarios, then we are thinking around it. Then we write the scripts until we find a solution or we find a way on how to solve the solution. So we'll be looking at the file new manipulation. Another thing is about users, like user management. And the other thing is about the networking bit. We didn't check into networking a lot. Maybe because currently we're using localhost machine, but there are times that we need to communicate various machine. So at least you need an understanding to troubleshoot a scenario, but maybe machine are not reachable and the likes. So yeah. So that's what we have. So our labs. So get ready. We check on our labs. So the first one is the text process manipulation. So the objective for this is to use text processing tools to analyze the etc password file and generate a report. So as we said, the user information is stored in these files. Although the encoded information like the password and the stored on another file, but most of the information is this file. So then we analyze from this file, then we get what we want. So the scenario is you need to create a report of all users on the system, then sorted by their user ID, unique ID that is, and then perform some basic checks for you to reach the objective. So I hope the scenario is clear and the objective is clear. So there are like steps on how we will reach to the outcome that we need. But also as we do that, you should also think, is it the right way? And also which is the better way we can achieve this, maybe in another apart from the way that I have highlighted here. So first you need to extract the username and the shells. So as you saw yesterday, that if you try to get the users, you'll see you have if it's a bash user or an unbash user. So you need to get the username and the shell. So on the file password, you need to cut the information from the file, get the username and the shell that the user is using. So that means you'll get random, like all the names. Then again, what you need go next is need to sort the users. So after sorting the users, so first you generate the file, then you use to a user row. Then after that, from the user row, you sort them, you get another file called a user sorted. So you have two files now. Then from the two files, from the second file is the user sorted now, you get users with the which their shell is bin bash. So from the file, you look for the users with, you grab the bin bash shell. So then those users, you put them into a file called bash users.txt. Then now you need to count the users of the system, because you have the regular users, then you have the system users. So the regular users and the system users, that are being identified by the UID number. It's either greater than 1,000 or less than 1,000. So that's the point. So you'll use those commands to get the information. Then after there, then is when you can sort and get the report that we are looking at first, which is the objective. So, so the final report you'll generate using this. So I wanted you to go through the overview on what we need to do. Then you can have your hand on deck. We do this lab so that we see shall we be able to get the report, and also we will go through each and every file to see the content. So I hope it's visible. I don't know if maybe the colors are not visible to you because you have red and black. I'll not be able to maybe to share. Yeah, it's okay. So can open your terminals and we do this lab.
Excuse me, is it possible for you to share the commands on like the chat? Because like yesterday I noticed if I'm trying to copy from here, it's like the spaces are not like very clear where it's supposed to have spaces or not. So could you please share the commands on the chat to avoid getting unnecessary errors?
It's okay. Let me get them for you. I have shared the file. Are we good? Can go through the output if you are done. I've seen a thumb up from one. The rest can have 2 minutes to finish up. Then we check on the output. Can go through the output. So let us do it together. So first we need to extract the username and put in the file user raw.txt. So we can cut and see the content of those file of the file. So you can see on this command we have cut D. So the information that we want to cut is on field 1 and field 7, which is the username and the shell. So what will separate them is the delimiter. So you can see minus D. Then full colon. So that's why we have this output here. So you can see we have root as a shell of bin bash, but we have daemon, which is as a shell of user, sbin, no login, and the rest of the users. So then we need to sort the information. So what we want to sort is we are sorting what is on the user row.txt into user row on this user sorted.txt. So we can cut also the user sorted and see. So you can see they have been sorted according to think alphabetically because that's B, D, G, I, till W. So they have been sorted. So you can see the same information, but we sorted them. So after there, then we need to get user the specific uh, shell. So we want to get users with the bash, the shell with bash. So that's why we are using the grep command. So on the grep, on the file user the sorted, we are getting those users with bin.bash. So then we'll store them on another file we call bin bash users. So here we are. So we can let's clear our shell first. I can have it here then. Let's cut bash users and see. So we have only 2 users with with bash. So then now we need to count users with who are regular and the system users. And we said what will differentiate this is all users with less than 1,000. That means and 999. Those are the system users. Anything 1,000 and above is the regular user. So we first create a file with the usernames and the UIDs now. So what we'll do is that we'll have this command. We'll have that command to get the information. Then after that, then is where we come to count the system users. So those are with less than 1,000. So you can see the system users we have 29. Then after there, we are moving to count the regular users. So that means the same command, but with greater than or equal to 1,000. A minute. Give me an error. So we're using a wrong annotation. So you can see the regular users, we have 2. Then the system users, we have 27. So that means we have a total of 29 users. So then now we need to get the final report from this. So on the final report, I will opt to run it as a bash, because the commands are many. But first you can just run it one by one, but it's a better practice to run it as a bash script. So now want to echo, that means this information here, user account report into a file called final report.txt. So we can cut that file. Find report.txt, so you can see that's the content of the file. So we can add information to that file, which is dates. So the same command again. You can see we have now extra information added. So I'm trying to format it to be presentable. So you can see, at least if you present it, it looks appealing. So now you want to have the users on, sorted.txt to the final report. But you can ask yourself, why have we used the double angle brackets? This is because you don't want to replace the content. Instead, you want to append it on that file. So that's why when you run, you get that. And maybe when you cut that file, you can see the file is a bit presentable. Then you come to append another lines. So you can see at the top we have the broken line, and also at the bottom. Then after that, want to append another information, the total users. So you can see it has taken the system users, which are 29. And now we can have the bash users. My terminal, seems to misbehave, but it's okay. can just type, because what we need is the bash users here. And what we need from here is also the bash users here. So you can cut the file and see. So it has a total users of 29. Then those with the shell of bash, there are 2 users. Now this is the report that we are looking for. So because that's the last command, cut the final report. So you can see the report we've manipulated different times to come up with a presentable report. So first thing that comes to your mind, that how long have we taken to do that? I think it was around 7:10 or thereabout until now, over 30 minutes or almost 30 minutes. You are doing that thing. But think this way: if you were to write a script and run that, then those commands would have been executed on a bash script. So we have taken maybe 10 minutes and they are done. Coming up with the script might take longer for the first time, but on the subsequent, then it'll be reusing the same script. So it will save you a big time. So yeah, anything that is not clear there before we proceed to the second lab, which is want to look on the user management, because we need to look at the user management as the second lab. So we are good. Move the next. Yeah, try to understand those commands, and also, I know you maybe for the first time you've copy pasted, but also try to get used to the keyboard. With time, you'll be able to memorize some of the commands, if not all, and the most common ones, the one you'll be using mostly. And also understand each and every command. So yeah, so that was all about the text processes and manipulation. So the another thing is the user and group management. So objective is to set up users and groups or hypothetical software development team, or development project. Then from there, you can have the scenario. So a new project called Project Zindua requires a dedicated team environment. So maybe the environment is on a Linux server. So you need to create a project group members and set up a shared workspace with the correct permissions. So that means the shared workspace is a directory. So in that directory, if the file that will be pushed there, these files, the members of that group should be able to have the correct permissions to work with these files and anything within that file, because that's their project. That's their project. So this scenario, first thing we'll do is to create a group, a project group. So the project group, we need to create it with the elevated permission. So that's why you need to have maybe the elevated permission you as the user will be creating for that. So in this case, what is the system administrator? So you have the privileges to do so. Then step number 2 is to create the user accounts. So maybe you have 2 users for that project. which is member one and member two. Then, yeah. Then step 3 is to set password for those users. Then step 4 is to create a shared workspace and also to give it to the appropriate users for that matter. And then after that, we need to set the permission, then lock an account. Then after we've locked an account, then we'll try to see, are we able to, is someone else able to access the account with the same permission or not. So let me share the commands again. So yeah, these are the commands, so can go through it. finish up in the next 2 minutes so that we can go through the same together. I think you're okay. So let's do it together now. So is my screen available? Terminal, that is. That's good, man.
I don't see a terminal.
That's a terminal?
I done something. Let me see.
I can see it. So. Like the Linux thing, yeah? Carries apps at DevOps machine.
Okay,
Yeah.
Let me rejoin.
That's okay.
Give me a second, I rejoin. Oh. Yeah, I can see it now.
Able to see the terminal?
Yeah.
So yeah, so the first command is to create the group. So our group, as we said, is called Zindua. So run sudo group add. Zindua. So then it will require us to input a password. So the group has been added. So the next thing now we need is to add account to those users. This command is to add the users. Now we need to add users to that group. So use sudo user add as SD2 group. So let's say user one is John. So in Linux, we have a tendency of running double commands with this. So, but now we just do command by command. Oh, sorry, we missed the group name. So then we do it for the same, but now maybe for Peter or for Joy. So now we have our two users. So the next thing we need to do is to set password to these users. So the password for John has been updated. Now for Joy. So the password for Joy also has been updated. So what remains there is to create the workspace, which is in our case is kind of folder for this project. So we started the group, but now we are doing the workspace. So make a directory, and the name of the directory is PT project Zindua. So now we need to set the group ownership to Zindua for this group, for this project. So here we are. So after that, now we need permission, because all the files that will be residing in this file should inherit the permission that are on the Zindua group. So we need to set the permission to the group. So as you know, the first bit of permission, we have the group level, we have the users, and we have the others. So we're using sudo, then so the first bit, which is the 2, so that one set SJD, then the 7, that means we have the root, then we have the group, which is Zindua, then we have the other. So the root will have explicit permission, then Zindua also will have explicit permissions, then the others will be having no permission. So that means other users who don't belong to that group will not be having permissions to this project. So now we can do various checks. We can do various checks to see if these permissions have been set correctly. So one of them, as we know, is ls permission denied. Let's run with sudo and see. Let's cd to it and see. I go to opt and then less minus l. So here it is, it's a directory. Read write execute. Read write execute. So the first one is the root. So you have the explicit permission 7. Then we have read write execute for the group, which is Zindua. Then the others don't have any permission to this folder. So the permission has been set correctly. So on that level, we are good.
So
now,
why is there an S instead of an X
where?
in the read write execute? It's for the group.
Okay. Yeah, it's an S by the. I thought I was not keen. Sorry. Why do you have an S? Maybe I found out. Then I'll tell you. Because it should be read write execute for the 2, then none for the rest. That's okay. By the end, I will find out. Then we'll let all know. So then now we can switch to another member and see if the member can do some operations. I think that command we missed, but it's one of the ways that we can test it. So for us to switch to a member, we need to have permissions. Which is, on this case, you can say John. Sorry. So you can see now the user we have. So John is a user on this group. So since we've been able to switch to John, then that means John can do operation. Hope with the next video you should be able to go back to our normal user. So that's how you switch between groups. That's how you switch between groups on Linux.
Can you please explain, you see that part where you cd'd opt and then ls and then lsl, but total 4 and then the drw. Can you just repeat what you said about that part, please?
So the first part, this is a directory. D, I think we saw this yesterday. Then the first two, this should be read write execute. Then also here should be read write execute. I don't know why it has given us S, but we'll check and no, because the first bit should be always is for the owner. Then on the owner, if you are not dealing with a group but on a user level, should be owner. Then we have the group. Then we have the others, the operation that someone can do on a file or on a folder. So in this case, then we have the root user, then we have the group level users, then we have the others. So if we come back here, we had said that the users on this group, where it is, we had said that the other should not have any permission to this folder. So that's what I said. Before the end of the lesson, we have to understand why it has given us S and not an X. But yeah, so this is the part. Like this, it's noted by D, like it's a directory. If it's a file, then you'll see that's noted by minus, like a minus. Let's see it here. No, we are still on the OPT. Let's go back to our root directory. Let's minus L. So you can see we have the directories denoted by D, then we have the files denoted by like a hyphen at first. So that's the concept behind this one here. So I think our time has moved, but we need to see on collaboration. So the last lab, I'll share with you the notes. Then on your time we'll do the lab on networking. We have the command there, so we can have a break of like 10 minutes. So by 8:25, let's come back and see on the part of collaboration and security on DevOps.
Niliwaambia jana msiegelee Spassky.
Yeah, hope you are all here. We can proceed. Is the screen visible first before maybe we tackle a question here? So there's a question Gita has asked about, can we have a script that automates the process of creating and managing users? Definitely, yeah. That's the best way, because here we have two users. It's easy to create them, easy to manage them. I have a question. I'll answer it at the end of the lesson. I have the point on the directory, so I've not forgotten. So if the users are one or two, it's easy to manage, or maybe they are on maybe one system, let's say one EC2 instance or one server. But take a instance where we have maybe three different servers. So these three different servers represent three different environments. Then these users should do it maybe on dev, then take it to the test, then to production. So will you be creating in each and every environment? No, that's not the way to go. The best way is to create to have a script. Then from that script, you can just SSH to those environments. So your script, what will do, your script, you should not be hard coding the names. Rather than, you should accept maybe something like a file. So you pass all your users on a file, a .txt file. You write all the users there. And also you set password there. So what you will do that once you run your script, then it will maybe ask you for the file. Then on the file, you pass the file. So it will get the file from the file location. But then this file location, that means the user should be given a option to go and reset the password on the first login, because you can't have my password you've created on the system. I should be able to reset it, because for security reason. Because if you have a username and a password, that means you can get into the system and do operation as if I'm there, so you'll be impersonating me. So that's the best way. So you create a file with the users, then you create your script, then your script should be able to accept the file and create the users on different system. If it's create the groups, create the users, give the users the permission that they need, and then we are good. Are we okay there? Understood? Yeah. So let's look at the DevOps security and collaboration. Two of the philosophies, or two of the, can say, is the pillars of DevOps. Security is a center of it. Collaboration is what is like the thing that made DevOps to be DevOps today, because collaboration on the teams that are working on the software, we have different teams working on them. But on the security also, what we are working on should be secure for use. So we'll start with the DevOps security. So on DevOps security, the code security, that's the first thing. Because DevOps will speak about many things, but the code is the center of everything. You are there to make code run well, make a system available, and our system are coming from the code. If it's application, then the source of application, we have a code. Then once we compile the code, then we have the application running. So we should ensure that code has no security. Code with no security consideration is prone to SQL injection and cross-site scripting. So that means your code, you can write a code, but the code, yeah, is working fine, but it has an attacker can pass security SQL injection or do a cross-site scripting. This is prone to the scripting languages, the likes of JavaScript and even Python. They are prone to the cross-site scripting and also the SQL injections. But a good code or a well-written code should be able to should not be able to prevent its the functionality to be attacked by attacker with these security threats. So to handle that, you need to scan your code with tools like Sneak, SonarQube for code vulnerabilities. So when these are flagged, they can be fixed. We have a couple of tools that are used to do this. We have the Sneak, we have the SonarQube. The SonarQube is for the static code analysis. So it will tell you about code smell, then it tell you about coverage, code coverage, branch coverage. So code coverage is where the code that you've written, then against maybe the test that you've written also. So how you've covered what percentage of your code. The minimum will be around 70%, 80%. So you should be able to have your functionality being tested to that extent. So this will also ensure our code is good. But also we have another tool called Trevi. So Trevi will scan about for vulnerabilities. It will also scan for both for the code and also for the base image. Then you have another tool called Checkmarks. Checkmarks is check for the maybe passwords or credentials that have been committed to the repository. So Checkmarks will usually it keeps checking on the repository, but also you can embed all these tools on your pipeline. In fact, so once your pipeline runs, then it goes through these checks. If one check fails, then you can say the pipeline should not be able to proceed until that check has been ticked or that issue has been fixed. So another place is on the ISC. ISC is infrastructure as code. So in the infrastructure as code, we have tools like CloudFormation, Azure Resource Manager, Terraform. We have Bicep in Azure. There are a couple of tools. We have Pulumi, it's used for ISC. There are a couple. The ones that are maybe common are the Terraform, CloudFormation, RM, because these are for CloudFormation it goes for AWS. So if you're an AWS user, most likely use CloudFormation. For Azure also, if you are using Azure, ARM, but for both with Terraform, you can achieve what you want. But also the automation that we are doing for our infrastructure, they are not that secure. If we do some security breaches, let's say for you to log into a cluster or log into your account, let's say an AWS account, you need the credentials. So if you commit these credentials on your repository with these files, Terraform files or CloudFormation files, what does that mean? That means the credentials have been exposed, because anyone who will get hold of the repository is able to log in to the environment and perform operation, which will be seen is you who is doing those operations, but in real sense it's not you. So you should consider that. So with misconfiguration of this will pose a risk on the infrastructure provided and managed, because also when you are provisioning these resources, let's say a resource like virtual machine on Azure, if you provision it, you need to pass, when you're creating, you need to pass a username and a password. So this username and password that will pass first, you should not commit them to a repository or a place where it will be accessed by everyone. But also, you should give is an option where the user, once log into the system, should be able to change these credentials. Because you don't know, maybe during the running of the script, as we said yesterday, if it's a script, log this information. So you should check what are you logging. You should not log everything. So sensitive data, mask that data. But in case, think a scenario where you've logged everything, username, password on plain text. This poses security threat for the infrastructure to be provisioned. So we have tools like TerraScan or Checkov, which enables to the point out those misconfigurations. So before you commit them, you can run through these tools so that you can see my infrastructure as code is secure and good for use. So the principle is the least privilege must be fully adhered to. So if you want to create a resource on an environment, let's say it's on Azure environment, you don't need an admin account maybe for you to do that. So use the least privileged user to create that resource. And also the user that will be granted access to that resource also it will be given the least privileges, like the privileges that they only need, not anything extra. So if the privilege will be only read only, should be read only. If we are only read and write, no edit. Not edit, but no delete. Because you might say, because the user has read and write, I can give permission to delete. No. If the user does not need to delete, why should you give the user permission to delete? So the security also is on CI/CD. So CI/CD is the backbone of deployments done for various environments. As we said, collaboration, CI/CD, this is part of automation in DevOps. Continuous integration, continuous delivery, and deployment. So on our CI/CD, with compromised pipeline, malicious code can be deployed to production. That's why I said those tools that I've talked about, Trevi, SonarCube, Snake, checkmarks, name it. You need to embed them on your pipeline so that they can scan your code. So also ensure no sensitive data are in your code or hard coded. So use tools like Vault to store them. Vault is for hash code, so you can store your credential there, then you call it. On GitHub, you have the environments, or you can store the environment variables. You can store your secret there. So you just call your secrets and use only when you need it. So there is no secrets or credential on the repository. There's no insensitive data. Let's say you are building your APIs. They use the developers coding APIs, but this API, there is API keys. These tools should also be used on, and they should be treated as environment variable. So once the application has been deployed on the environment, then now you can pass them on that environment. They should not be coming through the pipeline. So on the container and orchestration security, even if our code, we've scanned our code, it has been taken to the environment, let's say it's run on a server or it's run on a orchestrator tool, it's not secure though. We can scan it with Trevi, but the attacker, with time they will invade the environment. So you should also harden your environment. You should use gateways and network policy to limit and control the communication. So how? The tools like the gateways, one of you can, if it's on a cluster, you can use tools like HTML. So you'll be controlling the traffic. So that means you can have the rate limiting. So in a period of maybe 1 minute, you're saying I can only allow 100 requests. So because you know your service in that period, it cannot exceed that limit. So any excess traffic that will come, it will be blocked, because once the 100 has been reached, then excess traffic will be blocked. So that means if it's an DDoS, you've been able to mitigate it. But think a scenario where application is running, there's no any rate limiting, there's no control communication. So if it's a DDoS, then the service will go down, no bargaining there. So we have tools like Kibano and RBAC just to enhance the cluster security. So Kibano and RBAC is the role-based access control. So we are going back to the least privileges. So RBAC is a tool that can enhance things like the RBAC and other security controls on your cluster. Then we have the monitoring. Yeah, your environment is there, applications are running, but there's not any monitoring. So in case you're experiencing aside in traffic, like a traffic or an attack. The attack can also be monitored on the logging. So maybe you see a spike on CPU, a spike on memory, then you can think yourself, is this a spike? You first thing is which service is causing this spike. So you go down to check the service. Is it a service I know? Then why is it getting these spikes? Where is the traffic coming from? Then on real time, you're able to track down and see where the traffic is. It another service calling this service, or is it an attacker has been able to penetrate on environment and cause an DOS, or maybe it's an class and someone else has been able to deploy a bug, a malicious code. So the malicious code is consuming CPU and memory. As you can think, it's one of the trends also on the mining of cryptos. So if people are mining cryptos, when they get an idle machine, they can use your machine to do the mining. So you can spin your server, but all of a sudden, you're seeing as your memory and CPU has run out. So you are failing to understand what's going on. Your services are not able to run because the CPU has been exhausted. But in the background, there are bots that are being used by someone else mining cryptos, because maybe his machine has not the capacity. So he's trying to gather around as much CPU as possible and memory to perform the operations. So in case of a breach, you are able to see these things on real time. So use a centralized logging and monitoring. So if it's logged, you're able to see the logs, all the traffic that has been logged, and you can analyze the traffic and come out with conclusion. So you can implement CM tools for the threat detection and anomaly alerts, and also automate those alerts. So in case the threat instead of if there's that alerts can ping the moment security threat incident happens. So you can say get a message, an email, or a notification on various tools that are there. So we have compliance and governance everywhere in IT. Compliance is one of the main things, because the standard that has been set and you need to conform to the standards, and also regions, but also in industry level. So it depends on which industry are you working on. So this compliance and governance, you need to adapt to something like use policy as code to enforce those rules. So you don't need to every day do moving from maybe one pen to the next on an environment, let's say Azure, to say that if you are provisioning a resource, then the resource should be in a certain region, not in a certain region. Then why don't you create a resource and say for this resource group, it can only provision resources on this area or on this region. So you can automate them with the tools like AWS config and do scheduling of, like, can have schedule where regular you audit and state of the compliance, because the compliance is something that will catch up with you during the audit. So on audit, what they do is that they have been, the policies have been described, so I need to adapt to them. So the audit will come and check policy by policy. This policy says this, have you done it? Yes or no? Then they check, they move. So if you can do it as process code, then you automate the process. Then on a regular basis, you're able to audit your system before then you will escape much of the headache of the audit. So security-based practices, these are some of the security-based practices. So automate testing. We have the tools like we have Catalan, it's a testing tool. We have the Serverall. So you need to automate them as much as possible so that we don't have the manual interruption. And see, manual interruption, a tester can do testing of 3 to 4 services maybe has a couple of services, but when you automate them all, then that means all of them will go through the same system. But if it's manual, actually need to do that job, he may not do thorough testing for all services. He may test maybe the first 10 services and see they're performing well, then assume, oh, these all are coming from the same developer. So since these 10 have performed, then the rest have performed, so not do the thorough testing. So go zero trust. So no trust at all. Need to confirm everything, and all the time need to update your systems. Update your system, because system time they develop vulnerabilities. So if the patches, there's a patch and the patch is stable, need to patch your servers, and if it's your cluster, patch them. If it's your application, try to patch most of application. Let's say you're running Spring Boot application. Currently, I think we are around Spring Boot 4.0.3. So think of it, you are running a Spring Boot 3.5 there. So that means this Spring Boot this Spring version has vulnerability. So the vulnerability can be used by attackers. So you need to remediate them. So that means you need to upgrade your version of Spring. You need to upgrade the base image that you use by then, because they also have developed vulnerabilities, but also need to monitor constantly. Is my security still okay? Yeah, they need to train everyone and secure secrets. All of them, nothing should come before the other. Everything should be done almost the same time, because on training, if you train everyone that don't commit secrets, that means our secrets will be secure. Then if they've been trained not to commit secret, that means they will find a better place. Or if we have the security store tools like the Azure Keyboard or the Vault HashiCorp Vault to store the secrets, then we are good to go. So here we are. So these are some of the security tools. So code security, we have SonarCube and Sneak, scan code for vulnerabilities. For infrastructure as code security, we have the checkbox and TerraScan to validate the infrastructure templates. Then CICD security, we have the HashiCorp Vault and the Jenkins. So the Jenkins will automate, then the HashiCorp Vault will store our secrets. So secure the pipeline and secrets. Then we have the container security, where we have the Trivy and Qbench. So Qbench will sit on the cluster, then Trivy on our pipeline. Scan containers and harden clusters. Then monitoring, we have ELK Stack and Splunk. So they detect and respond to incident. Then on compliance, we have Prisma Cloud and AWS. So we automate the compliance checks. Collaboration. So this is the foundational shift on how teams design, build, test, deploy, and maintain the software. That's the life cycle of our software. We design, we build, we test, we deploy, and that designing to maintain the software is not a role of one person. There are a couple of people who come into place. So how do they work? So they should collaborate from the design to the maintaining. In case an issue has come out, then we take back to design, build. As we said, the cycle is infinite. So first, how do people on the collaboration have the functional, cross-functional teams? So we are breaking the silos. So integrated teams of developers, operation engineers, QAs, security experts, and business stakeholders are working together towards a shared goal. So because all of us, the goal here is to deliver for this organization or to deliver this product to the client, then we should all work together. We should bring our effort together. If it's a QA, do your work. If I developer, do your work. But in all, we consult each other on where we need more clarification. So from there, we will have the shared ownership, because all of us have been involved in the whole journey. Then that collaboration and the role blurring. So that means everyone is like, you can say my role is this, because you as a developer, QA needs you, but also you need you're needed by the QA. So everyone needs the other. Then on the CCD, I will not emphasize enough about this. But here is we need collaboration to deliver. So we have the early bug detection, we have the transparency, and reduce the risk. Because of the CCD, like SonarCube, we have quality gates we've set on SonarCube. When the quality gates they fail, that means the developer will get the feedback much earlier. Then that transparency. So if it's a bug has been detected, it's not me that I've said there's a bug, but you can see the tool has identified the bug and it has pointed where the bug is. If it's a code smell, if maybe you've passed credentials, you're able to be told these are the credentials. So there is the reduced risk. So that means you cannot take this risk or these things, the bugs to production. So in collaboration, we have also AIC still. So we are managing the infrastructure, servers, network, database, but the version control. So how does this happen? Let's say you're an environment where you need to manage servers, network, and databases, but you're not the only person who is doing this. So then you need a repository where you are pushing your files so that another person also can take it from there. Maybe you're doing an EC2 instance, someone else need to do a logic to provision a VPC. Another person need to do a logic provision, maybe load balancers and the network tables and all. So the developers define EC2 instances in Terraform config. Yeah, you just define the EC2 instance, then what the other guys, maybe the users will do is provision. I need an EC2 instance of Windows and of this CPU, this memory, and this image. So the operation will validate the compliance with security policies. So when we push it there, then we have the operational team or the compliance team. So they validate. Do we have everything that is everything in place? Have we followed the policies? So then these are the key collaboration metrics. So if you're collaborating, then how frequent do we deploy? So you can check from the CI/CD pipeline or the logs. If it's a daily, if it's a 3-day, if it's a weekly, then change lead time. Is it a less than a day? It commit to production. Then you have the mean time to recover in case of our downtime. Then we have the incident management system. Then we have the change failure rate. We've taken something to production. All the chances that we need to roll back to the previous version. Then that's why we have the rollback frequency. So I think that's what we have for today. But we have this. It is. So before we proceed there to this terminal, are we good on collaboration security? Or is there something that needs clarification? So yeah, so we'll come back here. There's a command that we ran here. So there's this command which said sudo change mode 2770. So that means when we say to these are, we've set that the users of this group, the users of this project, sorry, they should inherit the permissions from the group, not from their primary groups, because the permission may vary. So that's why you can see we have this S here. So this S here, it is. This S here. So this SCI is telling us that there's that JD, that SJD that we've set on our project for our users. So those users will be added to the group that we're using that project. So still, as we have the directory, read, write, execute for the root user, then read, write, execute, but the executable will be inherited from the group of the users on this project. Then they'll be added to this project Zindua. Then the others will not going to have any permission. Are we okay?
I have a question.
Yes.
It's regarding the weekly capstone project. Is there a brief for that or not?
I'll share the project then in case is everyone on the communication channel?
The Discord one.
Yeah,
26A
Discord.
DevOps.
Yeah, the Discord.
Yes.
Yeah, so I'll share the project. Then in case there's any clarification you need, I'll give as much clarification as possible. But in case you need any clarification, you can just pass the information there. Then I clarify where it's needed. Then there's a class on Saturday. I don't know if you are aware. Physical one. Are you informed about it?
What will you guys be doing on Saturday? Because I'm not able to make it. How can I compensate for it?
So I need to know how many will be available, because it's also depend on our availability. Are we going to available? If not, then we can see how we'll handle that part of Saturday, because it's also currently on Saturday we have been trying to get clarify on concept that maybe they were not understood, or we can do the project because it's a weekend. On Monday we need to start another module or another lesson. So on this day also we can do the project, so that Monday when we meet, then we can go through the project that maybe gave you some challenges. We go through together, then pick it for that week. So that's what you can do Saturday. We don't have a lesson for Saturday like we're doing this, because we need to catch up what have we been doing over the week, and maybe we reinforce or we build up on that. We do, if it's labs, 1 lab, 2 lab, because much of the classes will be hands-on, as you know, because we are here for the hands-on skill. We're not here to memorize the history of Git Bash and Linux. So she will not be around, and the rest, will you be available on Saturday?
Yeah, I can make it. About the projects, so are we going to show you, how do we show you like a finished? Are we going to post them on GitHub, or okay, like for example, this project?
Yeah, first you first need to put them on GitHub. Then there's that link on. Is it best? We'll be posting your capstone project. So there's those weekly lessons that we need to, like the assignment that we need to push them there. So on that, you will upload the link. I'll find the link and share with you how you can be uploading your assignments. So you'll push it to the GitHub. Kindly write a good README, because the README will the one which will guide me well on how if testing your project against the step that I have provided, and that is it. So push your code to GitHub, then give the link there so that I can follow the link. So kindly use HTTP links, because sometimes I can see people using the SSH or like the other format. Kindly use HTTP links or GitHub, and that will be good. I was trying to get the link, or Ezekiel will share with you on either Discord or in other channel of communication that is available. That are all there. So mwenye atakuwa ni mmoja ama have you received?